Hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. This is a worksheet on the distance formula. And the distance formula is kind of long, but it goes something like this, and I'll write it over here where the name goes. It goes distance d equals square root of x2 minus x1 squared plus y2 minus y1 squared. Whew, okay, that's a complicated looking formula. Let's look at where that comes from real quick and how you can solve this without doing that crazy formula, all right? If you're not good at memorizing formulas, then this method might be for you. So this will be for number one, something like this. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. All right, so 7 comma 3. I'm going to graph that. And then negative 1, negative 4. Negative 1, negative 1, 2, 3, 4. So about right there. Okay. All right. Well, they want to know the distance. So here's what they want. They want to know how long that is. Okay. Well, you can't just measure it, right? Like, I guess you could break out a ruler. If all of the, excuse me, if all the little tick marks are like the same length, if they're all like a centimeter long or something, I guess you could do it that way. But if you don't know, then the other way to do it would be to make a right triangle. And then you can count the spaces. 1, 2, 3, 4, 5, 6, 7. Right? So 7 spaces. What about this way? 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces. And I'm definitely going to need a calculator for this. I don't know why I didn't break out a calculator already. I'll bring out, let's say, a TI-30 X2S. Because why not? It's probably the most recent one I've bought. Looks something like this. You can see that. TI-30 X2S. Not an official endorsement. I don't get any money off of that. It's just one of the ones that I use. I use mostly TI. I've got a Casio as well. TI is probably the most popular, but anyways, rabbit trail. We want to figure out the hypotenuse. Well, if you want to figure out the hypotenuse of a right triangle, you do Pythagorean Theorem. A squared plus b squared equals c squared. Right? You might have seen that formula before, right? And if you're on the unit on distance, you've seen the distance formula as well. But the distance formula is a little harder. Pythagorean Theorem, would you agree that it's not as difficult of a formula to remember as the distance formula? If you disagree, let me know. If you agree, let me know in the comments. But I think this is a way easier formula than the distance formula. And it's actually the same formula, because watch this. If I take the square root of both sides, right, then I just have c. Let's put c over here, though. C equals the square root of a squared plus b squared. Isn't that starting to look like distance formula? Do you see it? C, D. I could change what the letters are. Change C to D. And what's A? It's the distance. The distance of, let's say, from left to right. So the x distance. X distance is the difference of the points, aka x2 minus x1. So that's where the formula comes from. But we've already counted up all the things. So we already know it's 8 squared and 7 squared. 8 is the distance horizontally. 7 is the distance vertically. So it looks something like that. And then I can just type it in. So the square root. And be careful if you're typing it in all at once, but definitely you want to get used to typing things in all at once, because it's way less work. 8 squared plus 7 squared and I get 10.6. And that's C. That's the answer. Okay. The other thing is, since it's a geometry problem, basically, right, even though this is Algebra 1, it's basically a geometry problem, so make sure the answer makes sense. If you look at the triangle, it looks like C should be a little more than 8 and 7, but not by a lot, right? It's like a little bit more than 8, but not a lot more than 8, right? So if, like, let's say you forgot to take the square to both sides, you would have gotten whatever 8 squared plus 7 squared is. That's a pretty big number. That doesn't make sense if you look at the picture. So definitely look at the picture. It'll help you to figure out if your answer makes sense or not. But this is really the backup. It takes a little bit longer to draw it all out, so it's not as fast as just using the distance formula. But this is a pretty good plan B. I would call this a good plan B. Plan B. Which is basically like this, and I won't write it out because I don't really have space for it. But the steps for plan B were basically this. You draw the picture, draw the XY axis, graph the points, connect the points, make a right triangle, Pythagorean theorem. Kind of those 5 things, right? Now, if we're going to just use distance formula, then all we do is we label x, y, x, y. And the first point doesn't have to be point with like a sub 1. That one doesn't have to be 1, but it doesn't matter, right? So if it doesn't matter, why not just count like you normally count? Just count 1, 2. So the first one, just call that x1, y1. And the second one, just call that x2, y2. Okay? And then you just plug it into the formula. x2, negative 3, minus x1, 3. Right? All I'm doing is plugging into this distance formula here. y2, 0, minus, don't forget to put that minus in between, because notice y1 is a negative 5, but it's minus y1, aka minus a negative 5. So be careful to include the minus sign in the formula, even if the number is also negative. Okay. That's going to be negative 3 minus 3, which would be like if you owe somebody $3 and then you borrow 3 more bucks. So now you owe them $6. Negative 3 minus 3 is negative 6. Negative 6 squared is 36. And then 0 minus negative 5 minus a negative. When you put 2 signs right next to each other, the signs are being multiplied. So minus a negative is actually a positive. It would be like a negative 1 times a negative 1 is a positive 1. 2 negatives make a positive. So minus a negative 5 is 5. And 5 squared is 25. Right? And the rest of that I'm going to do in the calculator because I'm kind of running out of space. I'm kind of squeezing in the answer as it is. But I would do the square root of 36 plus 25, close parentheses, enter. And I get 7.8. Right? And I'm rounding all of these to 1 decimal place. Some teachers prefer 2. If they do, then obviously, like, don't put my answer. Put, the answer rounded to 2 decimal places. So I'm not going to recap, like, how to round. But, yeah, definitely if your teacher wants you to do 2 decimal places, do 2 decimal places. And basically from here on out, we're also going to just use the distance formula. I might do the plan B option 1 or 2 more times. I actually like the plan B option better. Like if you're able to use graph paper as a separate sheet of paper, you could just, like, with enough colored pens, you could just use one graph, one XY axis, and then just graph all of them in different colors, and like color code which one is which. And you could do it that way. That actually wouldn't take as long, and it would be better, and it'd be less work. So I really like the plan B option. But for space reasons, we don't have enough space to do all that. So x1, y1, x2, y2. And it's x2 minus x1, y2 minus y1. And you can actually type all of that into the calculator at once. Since none of these happen to be Pythagorean triples, you would essentially you would have to use a calculator, right? So if you have to use a calculator, then why not use a calculator, right? So let's see here. We would do second square root, and then I'll need another. If you're not going to do any math, if you're going to type it in exactly how you see it here, I would do another parentheses, 3 minus 6 squared. Let me show you what I have so far. I'm going to pull it up to the camera here. Can you see that? Let it focus a little, right? So I have a square root, and then I have a parentheses 3 minus 6 squared. Because the first parentheses is to show where the square root starts. Okay. Plus parentheses -5. Make sure you're pressing the negative button. If you're going to type this all into the calculator, make sure you're putting in the negative button. Sorry, I keep having to clear my throat. It's a little scratchy right now. -5 minus a -7 squared, right? So you can see there's the 2, right? Plus parentheses. Notice that's a negative sign, not a minus. -5 minus -7 squared. Then I still close the parentheses one more time to close the parentheses on the square root. Then I press enter, and I get 3.6. Okay. If you do it that way, you can actually just type it in all at once. Okay. So here's what it would look like in the calculator. You would do square root, and each comma is just going to be the separation of which button you're pressing, right? So you press the square root button, which does this, typically. Then another parentheses. Then you do the x2, right? Type in the x2 minus the x1. Then you close the parentheses. Then you do the square button plus open parentheses y2 minus y1 close parentheses, then square it, then close the parentheses. And that's how you type it in to basically any calculator that's not a TI-30XA. If you have a TI-30XA, I'm sorry, your calculator is trash and you need to throw it in the trash. And not to rag on TI, because I like most of TI's calculators, but for whatever reason, the TI-30XA, I just really don't like it because it works backwards, and I don't like calculators that work backwards. But if you're restricted to a TI-30XA for, let's say, like the EOC, like an EOC or something, an end of course exam, there are other ones that you can use that have the same functionality of the TI-30XA that you could also use, besides just the calculator that pops up on screen. So that would be something like the Casio FX260. And there's another Casio you can use, and then I think there's a Katiga calculator. Let me know if I'm saying that wrong in the calculator in the comments. But there's a Katiga I think that you can use as well. But I would recommend, if you're restricted to, like, they tell you TI-30XA, you can actually do, as of right now, as of the time of putting this video out on May 31st, 2022, you can actually do a a Casio FX260, and that actually would be fine. So anyways, we get that 3.6, and that's it for that one. So I'm going to go ahead and type in this next one. I'm going to do the square root parentheses, okay, x2. What's x2? x2 is 5 minus x1, also 5, squared. plus parentheses. Yeah. I'm just following the steps here. That's all I'm doing. Just following the steps. Close parentheses squared plus open parentheses y2 negative 6 comma minus y1 which is 1 close parentheses squared close parentheses enter. Oh, look at that, it's 7. And this one is exactly 7 because if you were to graph this, these points are straight up and down from each other because they have the same x value. They're straight up and down from each other. So the distance between the points is literally just the distance between 1 and negative 6, which is 7. So the answer is just 7 on this one. Boom, 7. That's it. All right. That is it. Okay, time to change to another color. How about green? And let's just type it in. So again, we'll do x1, y1, x2, y2. All right. So if I'm going to type it in, remember it's square root, open parentheses again, because there's an open parentheses after the square root, x2, negative 8, minus x1, 5, close parentheses, squared. And if I'm going too fast, remember you can slow me down on the YouTube video. I'm just kind of going at a normal pace here. Plus, open parentheses, y2, minus y1, negative 8, close parentheses, squared, close parentheses, enter, 19.1. Right? And that's really all there is to it. So let's do it again for number 6 and see if you can stay with me at regular speed. If you didn't last time, it's going to be the square root of open parentheses x2 minus x1 squared plus y2 minus y1 squared, close parentheses, enter. And I get 12.04, which is just 12.0. Okay? So that's pretty much it. Now, we'll do it one more time, and then I think on number 8, I'll show you the graphing method again, just to switch things up a little bit. But on 7, here's what I'll do. I'll just be, what we can do is you can just, I'll just type it in, and you can let me know what you get for that one, actually. So actually, let's just do it one more time. So it's square root, open parentheses, x2 minus x1, close parentheses, squared, plus open parentheses, y2 minus y1, close parentheses, squared, close parentheses, enter. 6.4. Okay. Now, let's try that graphing method again. So, negative 4, negative 3. Negative 1, 2, 3, 4. Negative 1, 2, 3. 1, 4. 1, 1, 2, 3, 4. Okay. So it looks like that. And that's 1, 2, 3, 4, 5 spaces. 5 spaces there. 1, 2, 3, 4, 5, 6, 7 spaces. That way. Okay. And it's much better to use graph paper. I'm not using graph paper, but definitely suggested that you would use graph paper. So at this point then, if you wanted to type that into the calculator, you would do the square root of 7 squared plus 5 squared, close parentheses, enter. And I get 8.6. Okay. Now, here's what we're going to do. I'm going to break out another calculator here. This is the TI-83 Plus. And I have a program on here for doing the Pythagorean Theorem for me. So, oh, and the other thing, I have another program for distance formula, so I can just type in the points and do it that way. So what I'm going to do is I'm just going to type it into the program, and go ahead and solve number 9, and you can pause the video if you want, and solve number 9, and let's see if we get the same thing. Right, so I'm going to go to Dislomid, and maybe you already paused and unpaused the video. So I'm going to go to my program. It's called Dislomid, and this is one of my programs that I give to students that I'm tutoring in SAT prep, because as of the time of this video, you're allowed to use programs on the SAT. So I make programs and I give them to my students, and they're allowed to use them on the SAT as of the time of this video. Because really, the program is not doing anything that the calculator doesn't already know how to do, right? So, and I have to message real quick. Hold on. So what I'm going to do is I launch the program. So I just go in and launch the program, and then I just type in the points. So -2, enter, and I'll show you what it looks like. It looks like this. So I have all this text in there because when I write the program for myself, I make it a little bit more fancy since I know how to do, yeah, a little bit. I know how to do a little bit of calculator coding. Not super good at it, but I know enough. -6 and -8. All right, so I got all of them in there, and then I just hit enter, and then it spits out the distance, the midpoint, and the slope. Distance, midpoint, and slope. So the distance is 10.77, which rounds to 10.8. And that would be how you do it in a graphing calculator. Is you would use the distance formula as a program. That would be the best way to do it then, because you just type it all in and it spits out the answer. All right, and we could do the same thing on number 10. So go ahead and see if you can pause the video and get the same thing that I'm going to get here as well. 6, 2, 0, -6. All right, I'm assuming you pause and unpause at this point. I get exactly 10 on this one. That means that one was a Pythagorean triple. Very cool. I don't know why I decided to box that one when I didn't box the other ones, but hey, it's all good. So number 11, and let's do the let's do Pythagorean theorem on this one. So I'm going to keep doing different formulas. If you know distance formula, awesome. Just use the distance formula, right? So we already talked about that. If you know Pythagorean theorem, use Pythagorean theorem. If you have a program on the calculator, use the program. So I'm switching it up as we go here, right? Because otherwise it just gets kind of boring. If you look at the difference between them, the difference between -3 and -4 is 1. And the difference between -1 and 0 is 1. So that's just the square root of 2, which is like 1.4, I think. Square root of 2. Yeah, 1.4. Okay. So the other thing, too, is that it didn't say to round, which sometimes means they don't want you to round. Sometimes that means they want you to keep it as an unsimplified or an typed in simplified radical. So square root of 2 would be the answer then if they wanted that. And I haven't been doing that lately, so let's go ahead and do it that way as well. And let's do it the same way I was doing it on number 11. So I'm looking at the difference to get the distance. The difference between -5 and 3 is 8. And the difference between 4 and 1 is 3. Okay? So a little bit trickier to do it that way. But I'm not going to do it that way again and again and again. 73. So 64 plus 9 is 73. And I don't think that simplifies. So that would be the answer, unless you wanted to type it in and figure out what that is. I get 8.5. So it's roughly 8.5. Right? So either way, that would be what you would have for that. Here's how you would do it if you're doing the distance formula, right? So x1, y1, x2, y2. And we have, let's see, so x2 minus x1 squared, y2 minus y1 squared. So that's -1 plus 2, right? -1 plus 2 is 1. Oh, and I forgot to square root all that. 7 minus 3 is 4. And then that's 1 squared is 1. 4 squared is 16. and I get the square root of 17, right? So then the square root of 17 is 4.1. And again, I'm rounding all of these to one decimal place here. And that's what that would look like, right? So either one of those actually could be the answer. A lot of times, if they don't say what to round to, that usually means they don't want you to round. I'm actually kind of curious to see what they have for answers here. Ah, okay, so they didn't. They didn't round to any number of decimal places. They kept it as a simplified radical. Very interesting. Okay. And that makes sense because that's a lot of times, if they don't say what to round to, they don't want you to round at all. So, okay. Here's the other way, right? For number 13, x1, y1, x2, y2, -1 minus 8, -3 minus -5. Okay. -1 minus 8 is -9. Squared is 81. -3 minus a -5, so that's -3 plus 5, so that's +2 squared is 4. And then I have 85, which again does not simplify. It divides by 5, but I think it goes in like 17 times or something, because 85 doesn't really divide by anything else. Doesn't go into 2 because it's odd. Doesn't go into 3. 4, 5, goes into 5. 6, 7, no, it doesn't go into 7. 8, 9, 10, 11, doesn't go into 11. Might go into 13. Could be 13 as well. But yeah, so that's pretty much it, unless you type it into the calculator and let the calculator simplify it for you, right? All right, moving on. So we're going to go to orange now. And let's do the other method I was saying earlier again. So the difference method, the difference between 20 and 8 is 12. So difference means subtract, but if one of them is negative and one of them is positive, then you're actually adding. So here's how you know what the difference is. When you're taking a difference of two numbers, if they're both positive or if they're both negative, then the difference is really just subtracting them. I mean, you can actually ignore the sign as well. Like if they're both negative, you can ignore the negative signs. Totally fine. If the signs are different and you're taking the difference, you're actually adding. Because if you add a positive and a negative, you're actually subtracting. I know that's a little weird, but bear with me. If you add a positive and a negative, like +3 plus -2, that's the same thing as 3 minus 2. So if I subtract 3 and -2, it'd be 3 minus -2, which is 3 plus 2. So when you're finding the difference, do the opposite. 20 and 8 are the same sign. I'm going to subtract and get 12. -10 minus 6, I'd be adding and get 16. Square, square, root, like that. So basically, if you're going to write this out in steps, here's what you do in steps. Steps. You take the difference, you subtract the x's, right? So you subtract the x's, then you subtract the y's. Still with me? Subtract the x's, subtract the y's. 12 and 16. Square the x's, square the x's, or I should say x squared, right? So x squared. So x squared, y squared. Once you subtract them, right? And then add them, and then take the square root. In that order. So subtract, subtract, square, square, plus root. There's like 6 steps. Minus, minus, square, square, plus root. Minus, minus, square, square, plus root. Okay, so we already did minus, minus. We're going to do square, 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 and square. Then we're going to plus. Okay, so 0, 0 actually. 400. And then root, which is 20 actually. That's a pretty nice root. Looking to see if I had my charger nearby because it's my computer's yelling at me to charge it. Un momento. Is that my charger? I think that is my charger. Haha! I found my charger. There it is. Okay. We are back in business, people. Alright, so now, let's move on to the next one. Switch position here. Do kind of like a lean forward and thinking deeply. So, minus the negative 3 and the positive 15. So, negative 3 minus 15, I'm going to add them and get minus 18. But I don't need the sign, and I don't need the sign because I'm going to square it. And when you square numbers, they're positive. Except for 0. 0 is not really positive or negative. It's kind of like both. 0 is both positive and negative simultaneously. Okay. Anyways, so 17 minus negative 17. I'm going to add 17 and 7, and I would get 24. Okay. So I did subtract, square, square, and oh my gosh, why can I never remember 18 squared? It's like something I should know by now after doing math for so many years. 324. 324. And then 24 squared, 576. Okay. So then I add those, and I get, whoa, 900. That also has a square root. Look at that. Some nice square roots. So minus, square, square, plus root. Okay? So let me actually just show you what I would do in steps here in the calculator. If you're going to do this one step by one step in the calculator, right? Let's say you don't want to type the whole thing in at once. You just want to go step by step. Okay, we can do that. 11. Or actually, we would do it in order, I guess. You could do x2 minus x1 or x1 minus x2. Doesn't really matter. So let's say we do 11 x1 minus a negative 13. Okay, well, I get 24. Okay, what about step 2? Minus the y's. 11 y1 minus 8 is 3. Right? And I'm doing it in the calculator just to show you that like you can do each of these steps in the calculator one by one and then just do it all from there, right? So then step 3 would be to square the x. 24 squared, 576. Square the 3 and you get 9. Okay. Then you add them. 576 plus 9 is 585. And then you take the square root of that. Now, if you're using a TI-30XA, you can just hit the square root button and it spits out the answer. But that's the only way that it's not trash, because the TI-30XA is so trash. Okay, 24.2 is what I get, because I typed it into the calculator. Now, there's also a way to simplify a square root on a graphing calculator. There's a program for that too. So the program is not one of the things that I have in my original SAT course, but it is in the extended cut. So if you're interested in that, you can check that out on my website, myersmathematics.com. But basically, I would do RAD is what I called it, my RAD program. And I just type in the number 585, hit enter, and it simplifies to 3 root 65. And that's it. So that's what it simplifies to. Okay, cool. So then we're on to the next one. And notice we can type the whole thing in, right? So you can type the whole thing in, and you don't have to worry about it. We can do the rest of these just by looking at plugging them into the formula. All right. So basically, at this point, I don't know if I've not shown you anything that you haven't already any method that I don't know myself. So I think I kind of want to cut the video short just for time reasons. Now, some of these later on are kind of more complicated. Um, so maybe I'll do the last couple by hand in case you have to do these by hand. But at this point, especially if you're able to use a calculator, it's really not that bad. You can either use the distance formula, you can plot the points and use Pythagorean Theorem, or you can type it into the calculator all at once using what I put on number 4 here, right? Square root, parentheses, x2 minus x1, close parentheses, square, right? Step by step, that's how you would type it in, as long as it's not on a backwards calculator, like a TI-30XA. So I've showed you that method as well, right? Also, a couple other methods along the way. So I've shown you quite a few methods. Let me know, by the way, which method you like the best and which one resonated the most with you. But I think what I'm going to do is I'm just going to skip to the end and just work out the last two. And let me know if there are some others that you'd want me to solve as well. Let me know in the comments, and maybe I'll just solve those out as well. And I'll also have the completely done, filled in worksheet on my website, myersmathematics.com, which is also a link in the description below. So go check that out. Tons of free stuff on there, as well as some of my like full-on courses and things like that. The worksheets that I work out have the answers on there, and just tons of cool stuff. On the main page, there's a worksheet called not a worksheet, but like a PDF guide kind of thing, called the 5 math mistakes everyone makes and how to avoid them. So you can go check that out as well. Awesome free guide that I compiled just for you. Let's knock out the last couple here, and then we'll call it a day. So I'm actually just going to use the formula, x1, y1, x2, y2. Okay? So distance equals the square root of x2 minus x1, y2 minus y1. Right? So x2 minus x1 plus y2 minus y1 okay? So the square root of 2 minus a negative square root of 2. That's plus, so square root of 2 plus square root of 2 is 2 root 2. 6 root 2 minus a negative root 2, so that's 6 root 2 plus root 2, which is 7 root 2. Okay? And I'm going to need a little more space, so what I'm going to do actually is I'll probably just do the same thing for 28, but I'll not show as many steps. So from here, 2 root 2 squared. When you have things that are being multiplied or divided, and then all of that is raised to a power, you distribute the power into each thing that is separated by a times or a divide. Just like when you distribute. You distribute a number being times on the outside of the parentheses by every term, aka everything that's being separated by a plus or a minus. So kind of the same thing when you're distributing a square. The square gets distributed into everything that's separated by a times or a divide. So I'm going to square the 2 and the root 2. 2 squared is 4. Square root of 2 squared is 2. 7 squared is 49. Square root of 2 squared is 2. Okay, so then that's 8. 49 times 2 is 98, I believe. Yeah. 98 plus 8 is 106. Yeah. And then that divides by 2, goes in 53 times, but 53 is prime. So that would be it, actually. That would be the answer. Okay? That's it for that one. Now, here's what you could do if you wanted to go a little bit faster. You would subtract them up in your head, right? Because you just follow the steps, basically. Right? So I'm gonna just basically follow the steps. Minus, minus, square, square, plus root. Minus, minus, square, square, plus root. So minus, I'm going to kind of go like this. I'm going to, all that is right there. And then right here, there will be 28. Okay, so minus If I minus the x's, I would get 3 root 2. 4 root 2 minus root 2. Minus 8 root 3 minus a negative 7 root 3, so 15 root 3. Minus, square it. 3 squared and square root of 2 squared. So 3 squared is 9. Square root of 2 squared is 2. 9 times 2 is 18. Okay. So square it. 15 squared is 225 times 3. 225 times 3, 675. And let me check that in the calculator just to be sure, but I'm pretty sure I did that mental math fine. Just wanting to be careful. 15 root 3 squared. Yeah, okay. Just had to be sure. So now that I've done 1, 2, 3, 4, it's minus, square, square, add, root. So 675 plus 18. So 5 and 8, 13. Carry the 1. 7, 8, 9, 693. That's step 5. Minus, square, square, add, root. The square root of 693. If I'm going to take the square root of 693, here's how I simplify it by hand. Does it divide by 4? No, it's not even. Does it divide by 9? Well, 6 plus 9 is 15, plus 3 is 18. If I add up all the digits, 6, 9, and 3, I get 18, which does divide by 9, which means 693 does divide by 9. So I divide it by 9. And 9 would go into 69 7 times, with 6 left over, 63. 9 goes into 63 7 times again, which is 77. 77 is a fairly easy number to figure out what the factors are of if you're familiar with your 11s. 11s are all just, 2 of the same digit up to a certain point. So 77 is just 7 times 11. There's no other square numbers in that, so that's it. Square root of 9 is 3. And then you add the square root of 77. And that would be the final answer for number 28. So that is the conclusion of the worksheet. Again, I'm going to work out some of those other ones on my own time. That way the worksheet is completely done and filled in and everything. But just for time, I wanted to go ahead and just skip to the end there. Again, let me know if you want to see some of these worked out in real time. If not, you can just go to the website and get any of these ones between 18 and 26 if you want to see those solutions for those, or just the answers. If you want just the answers, you can just Google the worksheet. Usually it pops up right away. Just Google the distance formula, maybe Google Kuta software, and it'll be like the first thing that pops up if you Google all of that stuff. Okay, awesome. Well, hope this guide has been helpful. If it has, go check out my other stuff. Go check out other videos, like, subscribe, all that good stuff, and I'll see you in another video real soon.